Hello, 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 hello. Am I audible? Hello, hello, hello. Okay, okay, so I am audible here. So, let me just do some stuff. Okay. So in this live session, actually, I'm kind of nervous about this live. I haven't prepared much yet. I have this game, and today, because uh, like wait a minute. Um, okay, so uh, I'm back, and today we're gonna make an RL, reinforcement learning model, for this game actually. And I selected this game because this is a 2D, and we can use the same type of architecture for Minecraft bot too. So first of all, we will try to make an RL for hill climb, and then we will go towards Minecraft. So uh, I'm gonna use torch in here because I have I have RTX 3050, 6 gigabytes. As you can see here, it's a laptop GPU, and I have 23 gigabytes of DDR5 400 memory and a Ryzen 5 7235HS processor. And so we're gonna train on this GPU. For this, we can use JAX. So we're gonna use Torch. So first of all, what we gonna use is um, we're gonna use the reinforcement learning uh, for for this kind of work. I have a training data, as you can see here. I have 47,000 files, like images, alongside with their keystrokes. We can train on that too, but instead of doing that, we will try to use RL, so that it will be great, like it will be better. Okay, okay. So let's start doing it. Like programming it. Um, so as along as I will like code. I will tell what the code means and what it's gonna do. Okay. So let's start. So first of all, we will need libraries. We will need to import all the libraries that we need. So first of all, we need OS for doing my operating system and stuff. So first of all, let's import OS, and then we will need SYS, um, SYS, and then we'll need time for like sleeping for 5 to 3 seconds to like open the game so that the model can be trained on. Import time. Um, import R first as we're gonna use arguments and flags in here because we're gonna like do like start the script from the terminal, and we will need threading too. Okay, so we got threading, and then we need from collections we will need DQ collections, module collections. We will need import DQ DQ, and now for processing of images we will need CV2, NumPy, and below as they are great at processing images. So let's import CV2, import CV2, and then we'll import NumPy as empty, import NumPy as empty, and then we'll need PIL, this below from PIL. We'll need image. Now we need main AI stuff, that is torch, and then we'll need uh, torch.nm, torch.nm is nm. Then we'll need optimizers. For that we'll use from torch.optim import. Sorry. Uh, we'll do like let's do like this. Info uh info torch.optim as optim. Okay. And then we need we'll need torch genetic transforms, and lastly MSS. Uh, import uh, torch vision dot transforms as the and then we'll use PyAuto GUI, and because like other stuff like using keyboard or something won't work, as I have downloaded the game from Microsoft Store, and it's a kind of UWP which takes only hardware level keystrokes, and yet it is very strict about keystrokes. So therefore we'll make PyAuto GUI to do that. So we will import that. Import by auto GUI. So we don't need that. By auto GUI. Then identify model GUI dot wait. Let's just do in a try block so that it will be better. It will not give a long import error. Instead, it will give the statement instead of all the other stuff. Okay, so now let's just do the try block. Try the GUI
Mm-hmm.
and by other GUI dot PAU uh, PAUSE post by other GUI dot post by other GUI dot post. Wait, just like let's keep it zero and we'll make it fail safe. Um, other GUI dot fail safe is equal to false. Let's keep it false. Now, except import error with this import error will do system.exit will do file or to GUI was not found. Please use it, it install it install file or to GUI. Good. Next, we'll do Pineput. Yes, Pineput is also uh, like Pineput will be separate thing. If Pi auto GUI didn't work, we'll use Pineput. And most of the time, both works. But if it won't work, Pi auto GUI, then we'll use Pineput. Try we'll try import import uh sorry, we'll need from find good. We need find good instead of let's see find the keyboard and put it good import key and listen and listen. Right now let's do uh accept the import error. We do narcissist dot exit find Frankfurt was not found. Please use it and or find good take that um now okay, we have done this all. Now we will need configuration of a model. Um we'll do image all the configuration like image height, FPS, episode say seconds, how many seconds is that? How many seconds per episode, and then gamma, then LR, learning rate, then thresholds and stuff. Also do the save path. Now image height, comma image image width is equal to 135 down to 40. It's enough for the model to get enough details, and it will not much do pressure on the GPU. Next, we'll do episodes, yes, episodes. That will be episodes will be um episodes will be 100 episodes in total. Now, each episode will be so SCCS. Each episode will be 20 seconds, and then we'll do FPS into second 10. These are enough FPS for the model to learn. Next, we'll use gamma. Our gamma will be 0.99 as it is the discount factor. Discount factor, and also these are seconds. Seconds per episode. Now, for learning rate, we'll use 3e minus 4, and it is not much small, not much big. It's good enough for approx 700,000 parameter model. Next, entropy coefficient. TRO, so TRO coefficient. Entropy coefficient will be 0.02. This will encourage the exploration instead of the model finding some sort of shortcut to do the stuff. We'll do uh, we'll, do, we'll add an entropy coefficient that uh, makes the model to explore. Now, stuff threshold. If model will stuck, we'll use a threshold to remove that. Like a particular frames with no movement, and it will cause auto restart. Start PHI search or add the threshold to be, let's just keep 15 frames. So, and then countdown. Countdown will need like 5 seconds to open the game. So down will be 5 seconds. And then our save path will be path will be um, let's just save in the same directory as the script HCRL model dot pdtth. Let's see if there's any comments in here. Okay. Oh, okay. Great. Now, we have set up all the configuration. Now we'll use keys, the PyAuto GUI keys that the model will use. There will not be much keys, only right, uh, left, right, and enter. That will be return. And that's all. That's all the keys we need. like left for going left and right, like left for going backwards, right for going in front, and enter for restarting the game so that the game will restart. Let's do it. Try to GUI keys will be um let's I think should be red what what happened to this. Okay, nice one. No, five, to GUI. Hi, or GUI, keys is equal to, let's say, left, left key will be, left key will mean left, and right will mean right, and, enter will mean return. Okay, now, this is all our configuration. Now, we'll do achieve we'll do the policy for RL and initiation blocks and stuff. Um, so class class HC HCR policy HCR policy let's see next, and we'll name it dot module in here. Uh, okay. So policy for the model will be output. So it will be uh, on output policy for policy networks. These will like see and apply the stuff on the RL model. Output output. Let's say skewing three-way categorical nothing, like it will be three outputs, it will be nothing left or right, and enter will be binary, which will be like press enter to restart or not. That will be the we use enter for like for example we'll use enter for like starting. This is it. Yes, right. This is how it starts. And so here and output like die will be okay. Now previewing the chat. So coming up and here again for setting this is all for okay. So now let's use steering. For steering, it's three-way categorical. Three-way categorical. It will be nothing, either left or right. And next. Next we're going to for enter. Enter will use binary. Press enter to restart or not. Okay. This. Oh, okay. So now let's do the definition. Let's do INIT definition. INIT self. Next INIT self. Let's do super super dot INIT. Okay, great. Now self dot PATURS features is equal to n dot C n dot AC sequential. We'll use sequential, and then we'll use nn dot conf to the um nn dot conf to the that will be 332 32 and 5 will keep straight to and padding equal to straight is equal to 2 and padding also be 2 padding of 2 and then next which will be and then dot batch norm 2d that will be 30 32 32 and next we'll use array loop and dot array loop and then dot array loop to be true and not array loop true and next next the same we'll use 64 32 as input 64 as output. This is also okay so and then dot con con2d con2d and we'll use 32 64 and 3 let's click strike to again and then padding will be 1 next okay. Next it will be batch norm to be again it will be the same line but this time it will be 64 it will be 64 okay. uh and then batch norm to be okay this time it will be 64 next and ReLU ReLU that will be true ReLU will be true next and not again and dot on to okay config no, this time 128 comma sorry 64 comma 120 it will be 64 comma 120 and 3 3 comma straight moving to and padding will be 1 Next, we need batch batch norm to be will get 128. Wait, additional comma. Let's see. 128, comma, 128, 128, 128. Please write it equal to and padding equal to 1. Then we'll go back norm once again, and then uh, add up to average pool, and I guess it's it for screenshot, and then got the batch norm to read for 128, and reload, and then dot reload, it will be true. Okay, now lastly we'll and then dot adaptive to the adaptive adaptive average pool to be definitely 4.2. Okay, I guess. It's it. Um, good. Now, and then next, dot, so that issue equal to, and then potential, okay, and then dot Latin, and after that, after, let me see if anyone will have. Hello, okay, okay. Now let me turn off the sounds. Let's keep this in and turn on the music. Good. Now, now let's go back. Let's go here. Sorry, let's go in studio, and then then you will use and dot linear. Let me give a comment, and then dot linear 128 multiplied by 4. That will be multiplied by 4, and 256 comma, and then dot linear. So, right, now we go. Now, now we'll do steering. Let's do steering head will be nothing, nothing will be 0. 1 will be left, and right will be 2. Okay. Now self dot uh, steering head. Self dot steering head is equal to, and then dot linear, and then dot linear 256, 256 comma 3. Okay. Now we'll go to enter head into into head. Will enter head will be probability of pressing enter. Probability of enter. Correct. And now self dot enter head equal and then dot align and 2, 5, 6. Good. Now, now let's do the forward start from x feet feature will be feature will be self self dot features dot features x and shared is equal to self dot shared again self dot shared. Like which is created in self dot shared is equal to and the second shape. And we use Latin and then dot linear and the first feature. Yeah. Next, logics. Statistically are steering for logics. Um, so, steering and shape. Right. Okay. Right. Right. Comma and then now enter logics equal to self dot enter head and share share. And now I want to return the steering logics and enter logics. Okay, perfect. I guess our log class policy met is complete. Now, now, now we need to do is let's define like a definition that will load pre-trained model. It will try to load if they have a pre-trained model because I don't wanna edit this script again. So I will just put this in so that if they have pre-trained, we'll do RL training on that. Yet I guess I have one, but yeah, this is SFT. It's not RL, but still, if we want to use this, it can be that this is failed one. This is not that good. So yet, but still, I will add the uh definition load preaching model. Now here, if not try to load behavior behavior clone rates as 1%. Now, let's order if not os dot path dot is file path in then print rate um, at dot start. In this live stream, we will be doing a fresh one. But if you have one already done, you can you can use that one too. Uh, Yet using this load pretrain like use load pretrain definition, you can use that too. Now now let's return is equal to false. If this happens, then we return and test the class fully false. And then we'll use checkpoint, checkpoint, very good. Dot load that map location will be map location will be city city and then the image only because of will not be very soon. Next next will be state of the mall. State will be checkpoint dot get model state image checkpoint checkpoint model state and checkpoint. Next we'll do own state. Let me just once check the chat. Okay, it's good. There are two concurrent viewers and performance is 4. I guess please all confirm me that my voice is good. Please in comments. Let me know about this. Let's go back to code. Now own uh state will be uh dot state the dictionary state dictionary loaded loaded will be 0 and for new parameter in state dot. 。 items. 。 . 。 。 . 。 . 。 . 。 . 。 . 。 。 . 。 。 . 。 。 。 。 . 。 。 . 。 。 。 。 。 。 。 。 。 。 。 。 。 。 。 。 。 。 。 。 。 . 。 。 . 。 . there be if you in own state and own state name also dot shape is equal to rounds dot shape, then it will be own state is equal to own state name will be equal to the geometry. So, the plus is equal to great. Okay. Research. Example. Well, I guess I have messed up. Wait, there is no comma. Okay, now it's good. This forward. Okay. So it's okay now. Now we go here and model dot load uh model dot load state depth own state own state STRS to the strict is equal to all. Well, we don't need it to be strict. Yeah, it should be strict about this. And it's print f r loaded layers from uh, okay. This using this it will load the pretrained model return return true. Let's see is there okay okay return will be true. Great. Now I save. There's something wrong in wait. Um, syntax knowledge. Okay, let's use quick fix fix it. Can fix. Okay, I don't. Let's see what's uh, here. Uh, for me, if name and okay, it's still no comma, but there's still error, I guess. No, there's no. What? I guess last time it has fixed it with comma, but this time not okay. Okay, now the syntax is correct. Now, we have the stuff to load the pre-trained model. Now, let's go next. Now, will this definition will compute frame reward. That will be uh reward by frame. Okay. definition, definition, compute frames, compute frames, compute frames, report, there will be preview, preview, gray, GRAY, and then we will do this. We will base on how much the screen changed, which will mean that car is moving. Next, if previous grayscale is none, then return 0. Now, computing that is equal to CV2 dot ABS difference. Yeah, we'll use ABS difference from CV2 for calculating the difference. Current great. Now, mean difference. Mean difference will be NP dot mean difference. So what it will do is we'll use CV2 CPU's difference to calculate the difference between the previous image and the current image, and then we'll calculate the mean of that difference, and depending upon the difference we can give the model the rewards. Now we'll need to normalize to roughly roughly um -1, comma 1 and -1, comma 1 range and then the typical value will be typical values values will be moving approx 8 to 25 and stuck stuck will be approx 3 sorry 0 to 3 and then reward is equal to mean difference, the mean we just calculated, minus 3.0, that will be 4 divided by 10.0. Then return will strictly need float, then np dot click reward comma minus 1.0 comma 2.0. Correct. We got compute frames and reward. Now we need definition for playing one episode. Now, definition for play episode model, length model, device, it will be our GPU, CUDA, RTX 3050, device, and transform, transforms, transform, transform, duration, and FPS. Now, we'll use the one to store returns. It will it will return uh log props, rewards, entropy, and information USD and protect. Okay. Now we'll do monologue evaluate log props. Okay, no empty list rewards open empty list and entropy possibly list empty. Now let's see the action taken. The action that it would take. Action, action taken. There'll be there'll be nothing, nothing, and there'll be 0 and left there'll be 0 and right and extra 0, right 0 and also this. So now interval interval will be 1 divided by the number of FPS. Now previous three gray will be none and stop counters counter will be 0. Now the start time dot time current n is equal to 2 with mss dot mss mss monitor is equal to 3 dot monitor so that video can see this primary monitor. Well, now I turned off minus p start duration to be duration. So guys, can you please confirm? Uh, please confirm that you can hear me exactly. Okay, let's go back here. Okay. Now get your screen. I'll start to capture the screen. Okay, wait. Um, give me just a sec. Um, okay, I'm back. Okay. Will be equal to something to take a shot. That'll be a cd dot grab. It will grab the only one. Okay. Now frame RGB. Frame RGB is equal to cd2 dot convert color. Convert color frame or image or there we go. CV something. Okay. CV2 dot color BGR to gray to AI BGR to gray. That we convert it to grayscale. Now current current let me just exit some stuff. Okay. Gray current GR directory CV2 dot CV2 dot CD3 cv2.convert color, will convert colors to um, cv2.resize, 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 you can just set resize w frame pgr, comma, image width, the one we defined in the config, image width and image height. Great. Now cv2 dot color bgr to gray or bgr to gray, bgr to gray, bgr to bgr to gray. BGR to gray, and then we'll define the reward from the difference or reward from the difference of the frames. Um, as the reward from the reward from the frame difference, from the frame difference. Now reward will be equal to compute frames reward previous grade, comma. Okay, now previous grade, now current grade, current grade, current grade, previous grade and current grade. Now if frame n is greater than 0, then LB LB reverts reverts dot append reverts to append reward rewards dot append reward, and then set, reward from the frame difference. Now we'll make the start detection detection start detection. Now for start detection, if reward is less than minus 0.2, then the stuck counter stuck counter plus one plus one that is equal to sorry stuck counter will add one plus one else stuck counter will be zero. Great. Now finally we need model prediction. How the model will the model will predict according to this. Now PIL image is equal to image dot from array from array frame RGB tensor is equal to transform image low image dot unspace 0 and it will be to device device. Wait, what's wrong here? Pushing here. Stack counter. It's stuck. So it's stack counter and it's counter. Count. It's counter. Run. It's still the same. Else, um, oh, is something wrong with this? Okay, it's normal now. Okay, it's to device. Now with torch dot no red. Dot no red if frame and equals 0, else uh dot dot enable red enable red uh, steering logics steering logics comma enter logics um it's enter logics okay model tensor now uh, steering props equal torch torch max steering logics, document steering logics, and dimension will be -1. Dimension equals -1. Great. Now, steering distance equal to torch distributions distributions dot categorial um category AT category category we are steering steering probability steering steering action is equal to steering distorted sample. Now, as steering interval is drop equal torch dot sigmoid into logic. It will be into logic, and we're gonna squeeze it. Squeeze into logic dot squeeze, and auto enter. It will be entropy um auto enter. Sorry, uh auto enter it will be step counter. If it got stuck, it will do auto enter. Um, if step counter is bigger than step threshold, then it will do auto enter. Now let's log probability and entropy steer uh is equal to steering steering this steering list dot log log steering action steering action. Now let's do steer in row B equals steering this dot entropy entropy steering this dot entropy p steering this dot entropy entropy. Okay, it's correct. Now if frame n is greater than is is greater than 0, then log props dot append steer p, then and so append steer p, and then entropy dot entropy dot append entropy dot append steer and entropy steer entropy. Great. Next, now we'll need to execute the action. Execute action. Execute action. We'll need to release all the keys first. Release all keys first. For name in list held keys of try auto GUI try auto GUI dot key dot key up so key up um one or two keys. The one key is very given in the config prior to GUI dot keys, and then let's do name then held keys dot clear. Now this will uh held keys dot clear held keys dot clear. It will clear all the held keys. If any keys are held, it will release all the keys and it will be great. Then the model can identify out to you. I can give the arrow keys input, so the game will do the stuff. Okay. So now uh, uh, so so let's check. Uh, what micro exactly? Now, action IDs for steering down action S the steering STWR steering steering wait steering this steering steering action dot action dot item. Great. Now, uh, if auto enter, if auto enter, uh, uh, by auto GUI dot press return as if the card is turned, it will put the like press the return key. Start counter Stack counter is equal to 0 and actions taken uh, enter actions taken enter plus 1 plus is equal to 1. Okay, then if frame and if frame n is greater than 0, then reverse reverse um reverse it will be -1 equal minus 1.0. This will be penalty penalty for getting started. Now here I have action ID X is equal to 1. Action ID X is equals 1. Then by auto GUI dot add left add left actions taken actions taken left plus equals 1 and now ELA action ID X is equal to 10 by auto GUI by auto GUI dot add by auto GUI dot add um wait um key down key down by right now held keys dot add. There'll be right. Keys dot add. Right. Now actions taken. Actions taken. Right. Um. Add one. Wait. Add one in there. No. Else, if nothing happens, then the action taken will be nothing. Nothing. That right. Now update constant status. Um, um, okay, we did all the main stuff, and let's once save it. It's on. Okay, I have it saved. Let's one check the comments. There's no comments actually. Okay, it's great. Um, okay, so next we'll need to do is that we just okay, okay, we have written almost this much, and and okay, um, now okay, so main it is the main thing was this much, and I have shown you a live writing this. Yet I have this script, same script pre-written. So for now I'm gonna use that because it's already been so much time, and I don't wanna give much time. Because the live will be very much. So I'm gonna use that. Uh, Here I have made a clue to do some changes in there. So I just copy and just paste it in here. So now let's try to run and see what happens. Lower some noise. I guess this is almost zero. Now let's run the script. in 3 seconds. Let's okay, okay, it's starting. Now for tonight, today, I will learn as let's see what happens. Okay, you can see that it goes forward. Okay. Close it. Close it. Close. No, no. That not that. It will press the enter. Now start, please. No, I don't. I guess I don't have to use it. Okay. Just feel like it will open. Okay, yeah. I didn't know that the getting only the difference between the previous frame and the current frame. Now you can see that it is going further. That's why I always recommend to use the intro so that both of the notes will explore because only one note will be right. Okay, the bike is done. Let's go back. Let's go back. Okay, what happens? Okay, first we have to use gas. It's kind of slow that that okay now ready. Let me slow it. Slowly. That's it. It's kind of glitches here. love you. Oh, never. Oh, wait. No, that didn't happen. It has to go and just to wait. Okay. No, 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 don't panic, please. Just go. Let it go. Take it. Oh, wait. forward. Yes. You again, please. Okay, dead now. Roll. Just start the sound. What? I don't run. Run the gas. Run the gas. Run the gas. It's again running low. Low. Okay, dead again. It's dead again. Okay, come on, come on. It's doing lots more. Okay. wait, wait. Hey, oh, no, 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 no. Wait, wait, no. Wait. No, the backflip. Oh, but it's learning good. Oh, no, no, no. Right, again. Okay. No, not that much. Isn't too much. Not really. Oh, wait. Okay. This is all for this video, actually. I know you're expecting for Minecraft, but this was it's this the first version, and